Hi everyone, and welcome to a seminar as part of our new flagship seminar series hosted by the Daffodil Centre. I'm Cust, I'm the Deputy Director of the Centre, and I'll be facilitating the seminar today. So I'd like to start off by acknowledging the country that the Daffodil Centre founding institutions, the University of Sydney and Cancer Council New South Wales, are built on, and to acknowledge the traditional custodians of the land, the Gadigal people of the Eora Nation. I'd also like to pay my respects to their elders, both past and present, and offer my acknowledgement and respect to other Aboriginal and Torres Strait Islanders who may be present today. I'd also like to welcome our international speakers and attendees and our local and national attendees as well. Thank you for attending today. In terms of housekeeping, a reminder to the audience that the Q&A function will be active throughout the webinar. So don't use the chat, but use the Q&A if you have any questions for our speakers, and we'll be answering these questions during the panel discussion at the end of all the presentations. And so just to give a brief overview of the Daffodil Centre and this seminar series. The Daffodil Centre is a joint venture between Cancer Council New South Wales and the University of Sydney. The centre was officially launched on the 30th of March last year, so it's almost a year, and it brings together the strengths of both institutions to make an impact in cancer control. The centre's research supports policymakers, clinicians and cancer control agencies to make evidence-based decisions across the cancer control continuum and to generate the greatest impact at a population level. The flagship seminar series is an initiative of the Daffodil Centre to bring together international experts in the field of cancer control to discuss important internationally relevant issues. Today we're hosting our second seminar of this series, and it's focusing on precision prevention of melanoma. And of course, melanoma is very common in Australia and is often referred to as our national cancer. So in this seminar, you'll hear from leading international melanoma researchers who've conducted studies investigating whether precision prevention materials, in particular genomic risk information, can improve primary and secondary melanoma prevention behaviours. And so before I introduce the first speaker, I'd just like to start with sharing a little bit of background information and rationale for this particular topic. So as I said, invasive melanoma is common in Australia. It's the third most common cancer diagnosed. And we know that it's a highly preventable cancer through reducing exposure to ultraviolet radiation from the sun or from sunbeds. And most Australians are aware that traditional risk factors for melanoma and other skin cancers include things like sunburn, fair skin, red hair, moles, and family history. However, over the past 15 years, as researchers, we've learned a lot about genomic risk factors for melanoma. And we've discovered that genomic risk information is actually just as good at predicting an individual's melanoma risk as traditional risk factors. And there is additional predictive performance from measuring both types of risk factors. So we know that understanding and communicating risk of melanoma is important so that primary prevention strategies and early detection in the form of opportunistic skin checks can be targeted to people at high risk to complement the mass media campaigns and population-wide health promotion programs that are also very important in countries like Australia. So the challenge we've taken up as researchers is to understand how genomic risk information can be incorporated into clinical and public health practice in a way that's effective, sustainable, equitable, and cost-effective, and with minimal harms. So without further ado, I'm delighted to get this seminar underway, starting with two international speakers with whom our team has closely collaborated with as members of International Melanoma Consortia. So first up, we have Dr. Jennifer Hay. Jennifer is the Director of the Genomics Risk and Health Decision Making Laboratory at Memorial Sloan Kettering Cancer Center in New York. And she'll be giving us a presentation on precision prevention in the general population, identifying and overcoming real-world challenges. Jennifer's work focuses on optimizing the public health benefit of novel basic science, genomics and epidemiological findings in cancer through research concerning cancer risk perceptions and health decision-making, especially in cancer prevention. Welcome, Jennifer.
Can everyone see my slides?
Right, yeah, thank you.
Great, great. Well, thank you so much, Dr. Cust, for the invitation to speak today, and to the Daffodil Center for having these seminars. So I focused my talk today on the real world challenges of precision prevention, and really using melanoma prevention as a context for this, to look at how genomic information, precision information can both help us with skin cancer prevention, melanoma and other skin cancers, as well as reach health equity in precision prevention, two important challenges that we face in the world today. So the mission of precision medicine was really laid out over the last, I would say, 5 to 10 years. And in 2015, a lot of energy and attention came to this, at least in the US and worldwide, I think, as well, as this idea to use precise information as a way to empower patients, to really bring a greater sense of sort of ownership around risk factors and precise ways of handling those risks. And this was extended to the melanoma prevention context by Monica Janda and Peter Sawyer in around that same time, 2017, I believe, where they really promoted the opportunities that we face in melanoma to bring genomics and other risk factors to a precision context. And so around this time, 2014, investigators in the MSKIP project, including Peter Konetsky, who's going to be speaking with us today, confirmed across 17 studies worldwide that MC1R variants, common variants in the population, are responsible for sporadic melanoma and increased risk consistently and independently of phenotype. And the risks are in the neighborhood of 1.5 to 2.5 to 3, and very consistent across the general population. So Marianne Berwick and I, my colleague from University of New Mexico, were very excited about these findings and wanted to explore the translational potential in a general population sample. And so we developed a randomized controlled trial to look at the delivery of MC1R feedback in a population in Albuquerque, where there's year-round sun exposure, and about 50% Hispanics. Also very, very diverse in terms of health literacy, education, and other demographic factors. So this was a study that looked at, really quite equally efficacy as well as reach. So we were just as interested in the level of interest and uptake of MC1R feedback as we were in terms of efficacy, or whether this would actually move the needle for people on sun protection, screening, and other factors like communication. And we looked at some moderators that we thought would be potentially really important in predicting uptake and efficacy across general population samples. We developed a risk feedback brochure that included 4 pages. These are the first 2 pages And we based this on some early work that they did at the NIH, the National Institutes of Health. And we geared it for the melanoma context, the MC1R context. And so when people were tested, if they chose to be tested, they received this feedback pamphlet. And these are the second 2 pages, so that they received information about their risk in terms of visual, as well as a simple description, as well as these pages where they were prompted to ask their health educator questions, and also general advice about skin cancer prevention and early detection. We conducted extensive pilot studies with our population in Albuquerque to ensure that they were acceptable, comprehensible, and we did that in both Spanish and English. So in terms of the study design, we recruited 600 primary care patients, and we randomized them 1 to 5, either to usual care or an offer of MC1R testing. And so with this offer, they were not required to be tested. We wanted to actually look at the extent to which interest and uptake would be, common across this population. And then we assessed 3-month follow-up and had a quite acceptable 3-month follow-up rate of 82%. So I want to just spend a little bit of time talking about the high-level results for this trial, and really kind of focusing on these real-world challenges. So first of all, if we build it, will they come? So, just because we all may think that this is a valuable strategy for precision melanoma prevention, it doesn't necessarily mean that our population will come running for it. So we wanted to look at 2 dimensions of reach. One, participation in the study or refusal to do so, and decision to pursue testing or not deciding to pursue testing. And these 2 factors were completely unconfounded in the study, so you didn't have to get tested in order to participate. So just talking briefly about study refusal. So clinic patients were more likely to refuse the study if they had lower educational attainment, had lower perceived risk for skin cancer, or had higher uncertainty about their skin cancer risk by reporting that they did not know their skin cancer risk. Refusers also deprioritize learning about genes, which certainly makes a good deal of sense. When we controlled for education, the psychosocial factors remained important. As you can see, perceived risk, don't know your skin cancer risk or uncertainty, and importance of genes continue to be important in refusal. And just as an aside, there were no other demographic factors that predicted refusal other than education. So moving on to interest and uptake of testing. So about half, or 46% of those who were invited to log on to the website actually did so. And then after they logged onto the website, most actually requested a saliva sample test kit that was sent to their home, 88%. And then most of those who received the test kit in the mail returned it with a saliva sample, 82%. And in terms of the demographic predictors of these 3 outcomes, for website logon, non-Hispanic whites and those with a higher educational attainment were more likely to log on. And those with a sunburn history were more likely to request a test. And phenotype was not important. Other demographics were not important in terms of uptake. Now to move on to the second real world challenge is, if they come, if they want to be tested, will they respond well to the results? And what I mean by respond well is is looking at, cognitive as well as affective responses to the results. And I think we can see here optimistically that the responses to MC1R feedback at 2 weeks were quite good. So positive affect and receptivity were very high. And negative responses, negative emotional responses were quite low. And then overall distress levels, as measured through the IESR intrusive thoughts subscale, which is commonly used in this context for genomics, was extremely low. So a mean of 8, with the range being 7 to 21. So positive responses high, negative responses low. So then to just move on for a few minutes and look at results. 3 areas that we were really interested in terms of the real world impact is, will they act? Will risk results cause people to be motivated to make some changes in their sun protection and screening? Who, if anyone, might be harmed by this feedback? Also very important and something that we need to keep our eye on throughout. And then finally, are there certain subgroups who might be especially benefited from precision prevention information? So looking at the change in the primary outcomes at 3 months, we have a very mixed bag here. So to look at sun protection over time, this is from baseline to 3 months, we see that we were not able to move sun protection very much. And in fact, this could be because we had a bit of a ceiling effect in that our primary care patients in Albuquerque were already performing sun protection fairly well. So we have not a huge impact on sun protection outcomes. But optimistically, we were looking for those who had average risk findings to see if they would actually reduce their sun protection and take more risks in the sun, and we did not see that. So that's one harm that is often asked about in this context, is if we deliver genomic findings that show average risk or no mutation or even variants of uncertain significance, that will cause people to take greater risks in terms of their behaviors, and we did not find that. Also optimistically, we did not see changes in worry. So we might have seen that the higher risk group actually became more worried over time, and we did not see that. As you see, worry was low and very flat across the entire time period for all of our 4 important groups. And in terms of skin cancer screening, again, we did not see a huge change by group. And so, a very mixed bag in terms of our findings. Intriguingly, though, we did see significant moderation for baseline perceived risk. So for those participants who felt their skin cancer risk was very low at baseline, they were more likely to be responsive to higher risk feedback to increase their sun protection. So it could be that for those who feel their risk is low, MC1R feedback really serves as a teachable moment to promote sun protection. We did not see that effect for those who already thought that their risk for skin cancer was moderate to high. So in closing, so precision melanoma prevention may be underutilized by certain groups, those with lower educational attainment, those with lower or uncertain risk perceptions. And intriguingly, as you see, these may be the groups that are most likely to benefit from it. So something very important for us to keep in mind with future research. Participants generally found the test results to be believable and clear, and testing distress was very low. Our behavioral impacts were negligible overall, but strongest in those with lower risk perceptions. And importantly, harms were not found. Average risk feedback did not prompt risk behavior, and testing and higher risk feedback in particular did not prompt cancer worry. So, just thinking about next steps, I really believe we need hybrid implementation studies where we really focus on maximizing both access, participation, and on one hand, and effectiveness on the other, so that we're really focusing on those with higher risk profiles and those who may, may turn away a study like this, and we have to kind of do a little bit more to recruit those who may have the most to, the most to gain from it. So I wanted to thank our SOMBRE research team, Memorial Sloan Kettering Cancer Center, my institution, as well as the University of New Mexico. Here we are a couple of years ago, and I miss working with everyone, and yet still writing papers. And also wanted to thank the Genomics Risk and Health Decision Making Laboratory at Memorial Sloan Kettering Cancer Center. So thank you very much.
Thanks very much, Dr. Hay, for your presentation. And just a reminder to use the Q&A if you've got any questions, and we'll discuss them in the panel discussion. So from here, we're going to introduce Dr. Peter Konetsky, who is the chair and program leader in the Department of Cancer Epidemiology at the Moffitt Cancer Center in Florida. Dr. Konetsky has made seminal contributions to our understanding of melanoma and testicular germ cell tumours. His current research projects focus on genetic factors associated with risk of melanoma, influence of genes on immunotherapy for melanoma, and the impact of genetic susceptibility knowledge on melanoma risk reduction behaviour. And today he'll be presenting on randomised trials of precision prevention materials to improve primary and secondary melanoma prevention activities in the US. Thank you, Peter, and over to you.
Thank you so much, Anne, for the invitation to speak, and thank you to the Daffodil Center for this great seminar series. Let me share my slides. I think that should be good. So as Jennifer had alluded to, rates of melanoma in the United States are on the rise. Currently, it's the 5th most common cancer in both men and women in the United States. And in 2022, just shy of 100,000 individuals are expected to have a new diagnosis of melanoma. And I think most importantly, in contrast to other cancers for which incidence is decreasing, melanoma continues to rise. And this rise is also evident from some data sources among Hispanics in the United States. In Puerto Rico, which is a Commonwealth of the United States, Puerto Rico experienced a 300% increase in all cancers, including squamous cell, basal cell, and melanoma in the years 1974 to 2005. And for melanoma, health disparities exist. Over 25% of Hispanics are diagnosed with regional or distant metastatic spread, leading to poorer survival. And as Jennifer alluded to with the MSKIP study in MC1R, melanoma is MC1R is a robust predictor of melanoma incidence, and particularly among those who have what can be coined as a sun-resistant phenotype. And that finding really was the crux of the first precision prevention study that I started when I moved to the Moffitt Cancer Center 8 years ago. And this was particularly targeted to individuals with sun-resistant phenotypes, and that was an eligibility criteria. So these were individuals who had naturally dark hair, who reported little freckling, little propensity to burn, good propensity to tan. Participants were recruited between September 2015 and 2018, and the study was set in the family medicine and general internal medicine clinics at the University of South Florida, which is where the cancer center sits. And our hypothesis was that individuals with limited melanoma risk phenotypes who are told that they're at increased risk for developing melanoma because they carry higher risk MC1R variants would increase melanoma prevention behaviors. And the aims were focused both on primary prevention as well as secondary prevention, including self or partner skin examinations and skin examinations from health professionals. We also had an exploratory aim that was focused on whether or not adult participants who had children, would their children change behaviors because of the parents' knowledge of their increased risk due to MC1R. And the second study I want to talk about is essentially a sister study, but it is only enrolls Hispanic individuals. And this study was done as a partnership between the Moffitt Cancer Center and Ponce Health Sciences University in Puerto Rico. And these two institutions share a grant from the National Institutes of Health to advance cancer health equity. And the same hypothesis held with Hispanic participants who are told they're increased risk for developing skin cancer. And here we enlarged it beyond melanoma to also include basal cell and squamous cell carcinoma, because MC1R is a robust marker of skin cancer incidence overall. And would Hispanics change their primary and secondary prevention behaviors? And again, this exploratory aim that was asking the question of, can we also have, quote unquote, some transgenerational effect where we would affect the behaviors of the children? So participants were approached prior to their appointment and screened for eligibility. And this included either a self-report of sun-resistant phenotype in study 1 or self-report of Hispanic ethnicity in study 2. And after signing informed consent, participants provided a saliva sample and completed the baseline questionnaire. DNA was sequenced to determine the complete MC1R genotype. And after categorizing variants as either average or higher risk, participants were block randomized to receive either precision prevention or standard prevention materials. About 2 weeks after the materials were mailed, they received a call from the study group. And this call wasn't meant to reinforce any information, but rather assure that the intervention materials were received. And we did field any questions directed from the study participants. Follow-up occurred at 6 and 9 months in the first study, and at 6 and 12 months in the first study, and at 3 and 9 months in the study among Hispanics, the difference being simply the overall length of grant monies that we had received. And we had to do a delayed crossover. So at the end of the study, individuals who were randomized to the standard arm actually received precision prevention materials. This is just a schematic of our block randomization. So among individuals with average risk variants, they were block randomized to receive standard or precision materials. You can see the study numbers, about 225 in each arm for the first study and about 200 for the Hispanic study. And higher risk variants were a conglomeration of variants that impacted skin cancer risk or melanoma risk to a degree of about an odds ratio of 1.8 or above. And again, you can see the numbers there receiving each of the two arms. So for standard prevention, we provided information that was available from the American Academy of Dermatology that was adapted by Moffitt's marketing team. And we also included some information that was targeted to children. And for the precision prevention, we used the materials that Jennifer had presented in her study. So we adapted those for our purpose, but in essence, these are identical to the information that was provided in Jennifer Somber's study, in part allowing for more general and overall interpretation across studies. In terms of measured outcomes, We assessed weekday and weekend hours during high sunshine, number of red or painful burns, the frequency of protective behaviors, including wearing a hat, a shirt with sleeves, sunglasses, seeking an umbrella or shade while out in the sun, and also applying sunscreen. We assessed frequency of intentional outdoor tanning and intentional indoor tanning. The frequency of indoor tanning was quite low, less than 2% in both of our studies, so we didn't analyze that any further. And we also assessed skin examinations either by oneself or partner, as well as by a health professional, and assessed cancer worry. We can see here that about 71% completed both the 6-month and the 12-month in study 1, and about 50% completed the questionnaires in study 2. And we combined outcomes for the 12 and at the 2 follow-up points because we had continual recruitment into the study. So in essence, what we were testing with our statistics was a pre versus post intervention outcome where some type of average was the post intervention outcome that utilized weights coming from the first and second follow-ups. So for study 1, among individuals with sun-resistant phenotypes, individuals at MC1R average risk showed no intervention effects for primary prevention activities, although we did observe statistically significant improvements in weekday and weekend sun hours in the sun, number of sunburns, frequency of intentional indoor tanning, and wearing hats often or always within both the standard and the precision prevention arms. And these within arm differences are shown above this little dotted blue line. There were no intervention effects for secondary prevention activities, including skin examinations conducted either by oneself or a professional. No intervention effects for cancer worry, although we did notice within arm differences. And the results were similar for our second study. No intervention effect was noted among individuals at MC1R average risk. In contrast, several intervention effects were noted among participants at MC1R higher risk, and those receiving the precision prevention materials were twice as likely to seek shade or use an umbrella often or always, and to wear a shirt with sleeves often or always, compared to those receiving the standard prevention materials. For other prevention activities, primary prevention activities, we didn't notice any intervention effects, although we did again see some statistically significant improvements within arm. Cancer worry decreased among individuals in both the precision and standard prevention arms, with a greater decrease resulting in an intervention effect. And there was no intervention effect for skin examinations. And in the study among Hispanics, we did note that those receiving the precision prevention materials were 80% more likely to use sunscreen often or always. Other primary prevention activities were not affected by the intervention. However, we did see a fairly strong intervention effect for skin examinations conducted by a health professional, with those in the precision prevention having over a 6-fold more likely to have the skin exam. And cancer worry was decreased among participants who received the precision prevention materials compared to those receiving the generic prevention materials. And interestingly, although only 13% of participants in either study reported having a child less than 10 years old, despite these numbers, participants who are at MC1R higher risk, who completed the outcome information for their child, they showed decreases in the number of weekend hours their child spent in the sun, total number of sun protective behaviors, often or always, were higher, and the number of sunburns decreased. So in summary, regardless of whether participants received standard or precision prevention materials, many prevention behaviors tended to improve as anticipated among participants who carried only MC1R average risk variants, The precision prevention materials did not impact secondary or primary prevention activities, and importantly, did not impact cancer worry, nor did it result in decreased prevention behaviors, which could have arisen due to a false sense of security, not being at increased risk. And as hypothesized, among participants classified at MC1R higher risk, precision prevention intervention improved some sun protection activities and increased receipt of skin examinations. It also resulted in decreased cancer worry and improved some primary prevention activities. And with that, I want to thank my research collaborators, both at Ponce Health Sciences University and at Moffitt Cancer Center, both in my Department of Cancer Epidemiology, Biostatistics and Bioinformatics, as well as Health Outcomes and Behavior. Thanks so much.
Thanks very much, Dr. Konetsky. Next, we'll hear from Dr. Amelia Smith, who is an early career researcher based in my team in the melanoma and skin cancer stream in the Daffodil Center. Dr. Smith has expertise in epidemiological and qualitative research methods, and she was the project manager for the Melanoma Genomics Managing Your Risk study, which was an Australian NHMRC funded national randomized controlled trial, which underpinned her PhD research. And actually, as part of her PhD, Amelia spent a few months with Peter over in Florida, so got to immerse herself in his studies as well. Dr. Smith will be presenting the main findings from this randomized controlled trial in Australia, looking at the impact of personal genomic risk information on melanoma prevention behaviours and psychological outcomes. Welcome, Amelia.
Thanks, Anne, and it was a real highlight of my PhD to be able to have that visiting scientist placement with Peter. And thank you for the opportunity to present today. So, our study team conducted the Managing Your Risk study to evaluate our hypothesis that giving the public information on personal genomic risk of melanoma will motivate reduced sun exposure and increase sun protection and early detection behaviours with no psychological harms. We also hypothesised that the behavioural effect may differ according to the presence of traditional risk factors, such as a sun-sensitive phenotype or a family history of melanoma, because these factors might influence sun-related preventive behaviours and risk perception. So as Anne mentioned, this was a large population-based randomised controlled trial. We recruited people from across Australia through mail-outs from the Medicare Enrolment Database, which is the publicly funded universal healthcare system in Australia. And this was done over the spring and summer months of 2017 to 2019. To be eligible, participants had to be aged between 18 and 69 years, have no personal history of melanoma, and have full or part European ancestry. Of the total invited sample, which was around 36,000 Australians, 3.4% gave consent, and we found that this differed according to age and gender. And in the end, 1,025 participants were randomised to the intervention or control. So those participants randomised to the intervention arm received a mailed at-home saliva collection kit for collecting their DNA. And they received a personalised booklet describing their personal genomic risk of melanoma based on a 40-variant polygenic risk score, with the option to also have a summary of that risk information sent to their GP. And they were provided a general educational booklet with information on melanoma preventive behaviours, such as staying safe in the sun, using sun protection, and conducting skin examinations. And they also received a telephone call from a study-dedicated genetic counsellor. And that call was really just to confirm the receipt of the booklets and to answer any questions that the participant might have about their risk. Participants who were randomised to the control arm received only the general educational booklet. So this slide shows an excerpt from the personalised booklet that the intervention was provided with. The risk information presented as a risk category So lower than average, average, or higher than average risk. And we also use pictographs, similar to Peter and Jennifer's studies. And these showed the participant's own remaining lifetime risk and that of a person of the same age, gender, and residing in the same state as the participant. So this slide shows the distribution of the personal genomic risk estimates for the intervention arm only, because only the intervention arm underwent genomic testing, and the cut points that we use to determine the risk categories. So around 20%, 27% of participants were categorized at higher than average risk, 52% were at average risk, and 21% were at lower than average risk. The baseline measures were completed in the spring and summer months, and this involved all participants wearing a ultraviolet radiation or UV dosimeter on their wrist for 10 days, and also completing an online questionnaire, which took around 20 to 30 minutes. At follow-up 1, only a subset of participants were requested to wear a dosimeter, and at follow-up 2, all participants were asked to wear a dosimeter again. And at both follow-ups, we had a very high completion rate for the questionnaire. So here you can see the electronic dosimeters, and they're attached to lightweight wristbands. They measure UV exposure in standard erythema doses, or SEDS. And the primary outcome for the study was total daily SEDS measured using the UV dosimeters at 12 months after the baseline assessment. Analysis was conducted by intention to treat, and it was stratified by traditional risk group, categorized as high or low. And the traditional risk was based on a validated risk prediction model that included variables for moles, hair color, eye color, artificial sunbed use, first-degree family history of melanoma, and personal history of other skin cancers. The subgroup analyses assess differences in intervention effects, comparing intervention versus control arms across pre-specified subgroups, which are listed here on the slide. So in terms of the results, starting with the primary outcome, this graph shows the total daily SEDS at baseline and the 2 follow-up time points, comparing intervention in blue against control in red, and stratified also by traditional risk group. And the percentage differences between the groups are shown in the table. And as you can see, we found no difference in the primary outcome. So that was the total daily SEDS at 12 months from baseline between the intervention and control groups. But interestingly, participants in both trial arms did decrease their sun exposure over the course of the study, and that was a significant reduction. In the subgroup analysis of the primary outcome, we also observed an interaction according to genetic determinism. So this graph shows the total daily SEDS for the intervention, again in blue, and control in red, this time stratified by deterministic views. So participants with strong deterministic views had indicated on the questionnaire that they think genetics completely or moderately determine whether or not a person will develop melanoma. And those with weak deterministic views selected not at all, slightly, or somewhat for that question. At follow-up 2, there was a reduction in UV exposure comparing intervention with control arms among those with weak deterministic views, and increased UV exposure among those with strong deterministic views. Looking at the secondary outcomes now, for whole body skin examinations, there was no effect of the intervention overall or when stratified by traditional risk at follow-up 1 or 2. But when stratified by gender, the intervention increased skin examinations among women, but not men. And that was overall, and also when further stratified by high traditional risk. Looking at sunburns at 12 months, the intervention reduced self-reported sunburn incidence in the intervention versus control group by 28%. And the effect was particularly evident among the high traditional risk group and among women. So this graph shows self-reported sun protection behaviours based on a mean score of a 6-item scale measuring the frequency of sun protection use in the past month. So the higher the score, the more frequent the use of sun protection measures. And the table shows the mean differences between the study groups. And here we can see that the intervention improved self-reported sun protection behaviours at follow-up 1 among the high traditional risk group, but that this was attenuated by follow-up 2. In further subgroup analyses, we found that the intervention improved sun protection behaviours among older participants and those residing in an area with a higher socioeconomic indicator as well. So this graph shows the mean score for skin cancer related worry, and the higher the score, the higher the levels of worry. And interesting, the intervention reduced skin cancer related worry at 12 months overall and within low and high traditional risk groups. So that's another finding similar to Peter's. And regarding general measures of psychological distress, there was no impact of the intervention overall or according to traditional risk groups. So looking at the outcomes by genomic risk category in the intervention arm only, we found that UV dosimetry and skin examinations did not differ by genomic risk group. Those that received a higher than average genomic risk reported increased sun protection behaviours compared to those in the average or low genomic risk categories at follow-up 1, but this was not evident at follow-up 2. And participants who received a low genomic risk result did not worsen their sun protection behaviours. And as Jennifer pointed out, one of the main concerns about providing this information is the possibility of giving false reassurance and potentially encouraging risky behaviours for people who receive a low risk result. And we did not see this borne out in our results either. So to wrap up the Managing a Risk study, delivering personal genomic risk information had beneficial impacts on self-reported sun protection behaviours, sunburn and skin examinations, but did not influence the primary outcome of sun exposure. The impact differed according to population subgroups, with stronger effects, particularly for those at high traditional risk and women. And there was no evidence of psychological harm. In fact, melanoma-related worry was reduced. And these findings are informing a cost-effectiveness analysis, which is currently underway. So I would like to acknowledge the very multidisciplinary team of co-investigators who worked on this trial, including our team of fantastic research assistants, and I'll acknowledge the funding bodies, and these findings have been published in Genetics in Medicine. Thank you so much for your attention.
Thank you very much, Dr. Smith. And just a reminder that if you have any questions for the panel discussion, please put them in the Q&A. And for our last speaker before the panel, we have Dr. Julia Steinberg, who is a Senior Research Fellow at the Daffodil Centre. Her program of research leverages large-scale genomic, lifestyle, medical history and linked data to gain insights into human health and reduce the burden of cancer. Julia has extensive expertise in genetics and genomics and is now working on the opportunities and challenges of integrating genomics into cancer control. Her research focus areas include the development and validation of genomic cancer risk prediction tools to enable risk-tailored cancer screening and early detection for melanoma and other common cancers. Thank you, Julia.
Thank you very much, Anne. I'm really delighted to be here and to present our work on the evaluation of melanoma genomic risk scores, but also briefly introduce an exciting new program of research called the Australian Cancer Risk Study. Currently, there is no organised national screening program for melanoma and insufficient evidence to recommend for or against one. Opportunistic skin checks are common, and some observational evidence suggests that skin checks can improve early detection of melanoma. A key recommendation from the US Preventive Services Task Force in 2016 was for further research on targeted screening for people at high risk, and this is at the core of our work. In particular, as you've heard from the other speakers, genetic predisposition plays an important role for melanoma risk, with both rare variants that increase risk very strongly and likely hundreds of common genetic variants that only confer small risk increases. As you can see illustrated on the right, this means all of us likely have a combination of some of these risk variants contributing to our personal melanoma risk profiles. So-called polygenic risk scores or genomic risk scores combine information across known risk variants to predict people's cancer risk. We're interested in whether these risk scores and tools can be used for risk-tailored early detection in the future. In this particular study for melanoma, we evaluated some existing risk tools in UK and Australian prospective cohorts, and I will show you some selected results in the following. We considered two main polygenic risk scores, or PRS, one based on 45 independent risk variants known from studies up to 2018, and we also considered an analogous score based on the most recent large-scale genetic association study in 2020, with now 68 independent risk variants. As you can see in the figures, both PRS include mostly common variants, each conferring relatively smaller risk increases. To evaluate the PRS, we used data from two large prospective cohorts. The first is UK Biobank, with almost 400,000 participants and over 1,500 incident invasive melanoma during 5 to 10 years of follow-up. The second cohort is the Melbourne Collaborative Cohort Study. Here we have genetic data for a sub-cohort of about 4,500 randomly selected participants, as well as for all additional participants who developed invasive melanoma during the 10 years of follow-up, which is 303 cases in total. For both cohorts, these numbers are after restricting the analysis to individuals with no prevalent melanoma at cohort entry and those with European ancestry only, to exclude something that's called confounding due to population structure in genetics. We compared two approaches to predicting absolute melanoma risks, so the risk of being diagnosed with invasive melanoma within the next 10 years. In the first, age and sex-specific risks were calculated based on population-wide data for numbers of melanoma cases and deaths, as well as all-cause deaths. In the second approach, we used genomic data for individual participants and the risk variants from each PRS to calculate an age, sex, and PRS-specific absolute risk of developing melanoma. We applied this approach for each PRS in our study. We then asked whether the PRS-adjusted absolute risks could better predict melanoma incidence than the population-based unadjusted absolute risks. Here you can see the sensitivity and specificity of the absolute risks in UK Biobank, with the age and sex-specific risks in black, risks incorporating the 68 variant PRS in red, and risks incorporating the 45 variant PRS in blue. The figure shows that incorporating PRS information significantly improved the area under the curve, or the AUC, for absolute risk prediction, with again significantly stronger improvement when using the newer 68 variant PRS. Briefly, the AUC represents the probability that a randomly chosen case has a higher risk score than a randomly chosen control. These results show that incorporation of genomic information to risk prediction can help improve risk stratification for melanoma. And we found similar results in the Australian Melbourne Collaborative Cohort Study. We then evaluated the calibration of the absolute predicted risks, which is the agreement between the total numbers of expected and observed cases in a cohort. As you can see from the figure on the bottom right, the age and sex-specific risks from population-wide data actually underestimate melanoma incidence in UK Biobank. This is likely due to multiple factors, including that UK Biobank is not representative of the whole population in terms of socioeconomic advantage and health-seeking behavior, and that we only analyzed information for participants with European ancestry, who in general have lighter skin tone and higher risk of melanoma. This has knock-on effects for the PRS adjusted absolute risks, where we also see more observed than predicted cases, especially for the 45 variant score, as you can see in the figures on the left. The calibration analysis in the Australian cohort showed similar results. Now, calibration of absolute risks is important, as many cancer prevention and early detection approaches are based on absolute risk thresholds. So further research is needed to ensure appropriate calibration of predicted absolute risks before any application in practice. But our study did find that genomic information can help melanoma risk stratification. So I'd like to show you an illustration of the potential to support risk tailoring of the start age for melanoma early detection. In the left figure, the black line shows the population average risks of men in England and Wales by age. The purple and turquoise lines show the average risks for people with the 20% highest and the 20% lowest melanoma genomic risk respectively. As you can see, the population average 10-year risk of invasive melanoma for 50-year-old men in England and Wales is reached on average 15 years earlier for those in the high PRS group, and by contrast 15 years later for those in the low PRS group. The right figure shows similar results for women. And this illustrates how genomic risk information might help tailoring the start age of screening to different risk groups, although a lot more work would be needed to address aspects of collaboration, as mentioned before, and also to ensure the results hold for more diverse populations. And last but not least, evaluate the benefits and harms of risk-tailored programs. And this brings me to one final aspect I'd like to briefly outline today, which is some exciting new research that we will be doing on the potential of genomics for risk-tailored cancer screening and early detection. Genetic predisposition plays an important role not just for melanoma, but also for breast, colorectal, and prostate cancers. So together with the fantastic multidisciplinary team of collaborators, we've received funding to consider whether genomic risk prediction can help optimize cancer screening and early detection for these 4 cancers in Australia in a program of work called the Australian Cancer Risk Study. So over the next 3 to 4 years, we'll be working to address 4 key research aims. First, we will generate a new lasting resource of Australian genomics information, collecting DNA samples and generating genomic data for 10,000 participants of the 45 and up study, leveraging the existing in-depth lifestyle and linked health data. Second, we will use this new resource, as well as other large-scale Australian and international cohorts, to develop and evaluate cutting-edge cancer risk prediction tools that incorporate genomic information. In particular, we will quantify how well these tools could support classification at clinically relevant risk thresholds. Third, Dr. Alison Pearce at the University of Sydney will lead work using discrete choice experiments to establish public preferences for genomic risk tools and risk-tailored cancer screening and early detection, which is really crucial for the acceptability of any future proposed strategies. Finally, interfacing with other work underway at the Daffodil Centre by Professor Karen Canfield and team, we will model the benefits, harms, costs, effectiveness and cost-effectiveness of prioritized genomics-informed, risk-tailored screening and early detection strategies. This will help identify the best buys in cancer control. And ultimately, we hope that the Australian Cancer Risk Study research will enable evidence-based recommendations for whether and how the translation of genomic risk tools to practice can support sustainable, effective, and efficient cancer control. It remains for me to thank the many people who've contributed to this work. Our study on melanoma genomic risk prediction and the validation of 2 existing scores has been published by the British Journal of Dermatology and was carried out by a great international team whose pictures you can see here. And we're incredibly excited to be working with an amazing multidisciplinary team on the Australian Cancer Risk Study, with the names of people leading key components highlighted on the slide. Last but not least, thank you very much for your attention.
Thank you very much, Julia. That was a great presentation, and a great presentation from all of the speakers today. So now we have our panel discussion. So I will welcome back all of the speakers. And just a reminder that we've got the Q&A function that you can use to post a question, and some of them have already come in. I also have my own questions to generate discussion from the panel. But there are a couple of key questions that have come in that it might be good to address before I go to my other questions. And they are around costs and current availability. So I might, Jennifer, are you able to comment on the cost and availability of genetic testing or genomic testing in the US? And then I might come to Amelia for the Australian context.
Well, I guess when it comes to common variability, the best analogy is the direct-to-consumer context. And so, you know, prices in that context for genetic testing have come way down. And so it really depends on whether, you know, a study or, you know, a participant wants to pursue clinical grade testing, or whether they're pursuing direct to consumer, you know, like 23andMe kind of testing. But the costs are really pretty modest in that context. So it really, you know, I think it's definitely something that we need to explore in the general population, or else, you know, only the most informed people will be pursuing that kind of testing.
Thanks. Peter, did you want to add anything to that?
I also think there's a difference in what type of testing. So for example, you know, doing a SNP-based array for the 68 most GWAS hits for melanoma is a different assay than doing complete sequencing for MC1R in order to uncover the entirety of variation. So, you know, depending on what type of testing is requested or wanted or moves, you know, into the next steps toward more public availability, could also impact costs to the individual.
Thanks. Amelia, do you want to comment? And then Julia, I'll let you have a final comment on that question.
Yeah, so I suppose in the Australian context, direct-to-consumer testing is less prevalent, but is still available and is becoming cheaper here as well, from my understanding. Clinical testing, so for melanoma risk, I believe it's available to families at high risk of melanoma, so with a certain family history and or with a number of melanomas for someone's personal history as well. But the type of SNP testing that we did in our study is research-based, so it isn't available in the clinic.
And Julia?
Yeah, and maybe to add to what the other panelists have said as well, is that in addition to there being different types of testing, if the testing is done what's called genome-wide, so if we did a complete readout of somebody's genomic information, we would probably be doing that just once in their life. And that information could be used for melanoma, but it could also be used for other diseases where some prevention options are available, for example, obviously depending on the balance of benefits and harms of those applications. But so when we do think about the cost, it may also be interesting to start thinking about how that could be split across different applications. So it's not just for melanoma as well.
Yeah, that's a great point. Thank you. Well, I'm going to ask a question to get you thinking, and that is that based on the study results that have been presented today, do you think we should be routinely offering or providing, there's, I guess, an important distinction there, genomic risk feedback to the community, and why or why not, and what would you consider in making that decision? I'll head to Peter first.
Well, you know, in terms of efficacy results, I think that the overall flavor across the three studies, the four studies that were presented, is that we do see movement in many activities that could, you know, be characterized under primary or secondary prevention for melanoma or skin cancer. So from that perspective, it feels, it's a nice positive, particularly in contrast to some of the prior research that has been out there that has been more negative toward efficacy results presented subsequent to receipt of genetic information for some other cancers and or conditions. However, I think the work that, Jennifer presented, at least in the United States, really regarding uptake in the public, reach, making sure things are equitable, are still an open question that need to be resolved. And I love that, your study is population-based, but the rates of uptake are quite small. So while we really, like that aspect of, you attempted to get across the entire, all the variety of states, we have to think about what is the uptake going to be, and is it going to be equitable and meaningful to the other 96%, of Australia, or the other individuals in the States who we didn't touch, Jennifer nor I touched, because ours were university-based clinics. So we're working on some of those answers.
Thanks, Peter. Jennifer, do you have any additional comments?
It's interesting in the US. I can't imagine we get to a point where we're imposing genetic testing in the general population. I think we're always going to be reaching those who have the highest levels of interest, the highest levels of receptivity. And so really combining that with a precision approach to who might best benefit. So who's interested and who might best benefit. And so, there are subcategories of individuals who I think are really, kind of the prime targets for this kind of feedback. They could be, young women who will not stop indoor tanning, or, young adults who are, not using sun protection and therefore at higher risk, where there's a real need for a teachable moment. Really thinking about sort of the behavioral piece of that is, what are the subgroups where we can expect the highest level of bang for our buck or motivation to change. It may also be that we want to combine genetic feedback with other intervention modules, like promoting self-efficacy or action planning, so that we might actually do exceedingly well with a larger population if we can put those other pieces in place, so that we're moving people on multiple intervention targets at the same time.
Right. Julia, your presentation really was addressing the early detection and screening program, and of using these polygenic risk scores or genomic risk information, and you saw in particular an issue around calibrating the models. Do you want to just give your impression of how likely it might be in future that this type of information might be incorporated into those sorts of programs?
Absolutely. I think our study showed that there is definitely potential for risk stratification due to genomic information, so helping distinguish the high risk from the low risk groups. Now, as you said, calibration, that's the aspect of how well can we predict the absolute risk level. And that matters a lot for the screening or early detection program. If it has a risk threshold of something like 3%, say, we need to classify who's above or below it. Now, we do need to do a bit more work on appropriate calibration, but that can be achieved with more representative population cohorts where we evaluate and recalibrate the methods. So I think that there are some challenges there, but they're certainly addressable through future research, and that will help appropriate translation for strategies where the benefits do outweigh the harms. And obviously there's more work needed, as Jennifer and Peter were saying, to identify who the best target populations and the best and most equitable applications are.
Jennifer, can I expand on something that you mentioned around, maybe packaging it up with other information around, self-efficacy. I mean, one of the interesting things that we did see with our primary outcome of objective sun exposure was a statistically significant difference in the impact of the intervention, depending on how people essentially perceived, the genetic determinism in terms of how much the genetics sort of have a role in their disease risk. So how easy is it to change those sorts of thoughts? And yeah, how would you go about doing that?
Well, it depends on whether you conceptualize genetic determinism as a individual difference variable that is, that is fixed, or whether you see it as an element of a knowledge element, construct. So if we think of it as something that's changeable, that we can actually educate people to kind of, come to the middle in genetic determinism, that genetics are important, but they're not the whole story. I think that it could be thought of as its own element of knowledge that we want to actually increase and deepen, people's knowledge of those sorts of things so that they can best use genetic information for their benefit. So I don't see it as necessarily an individual difference variable per se.
Yeah, thank you. There's a question about whether these common genomic variants might modify the penetrance or the overall risk for more rarer variants that run in families. Peter, do you want to comment on that?
Mm-hmm. So in terms of association between inherited genetic variation and somatic changes, there has been some literature showing that high-risk variants at MC1R are associated with BRAF mutations. And I believe also that variants in MC1R are associated with tumor burden, mutational burden, in melanomas. So there does, at least for MC1R, seem to be some bridge in between inheritance and somatic changes. I'm less familiar whether or not that work, the work to the degree that it extends to polygenic risk scores that are more used in your studies.
Thanks, Peter. Yes, I think I got confused in the question because it was, asking about somatic and germline mutations. We have a question on whether the health of the whole family as a motivation. Sorry, what were you?
Yeah, I can take a stab at that. So this is a question about.
I'm not sure everyone. Yeah, can you read it out because not everyone will see it. Yeah.
Question is whether health of the whole family might be a motivator for behavior change, and was knowledge of family member experience of skin cancer a predictor of acceptance of genomic screening? I can't speak to the second part of that question because we didn't look at uptake in that fashion. But in both of the studies, in the study among sun-resistant non-Hispanic individuals, we did find that family history of melanoma was a moderating factor. Now, the interesting thing was most of our moderation for that study was in the average risk group, which we somewhat wouldn't have anticipated much activity there. But for wearing a hat often or always and seeking shade or seeking an umbrella while outside, if you had a family history of melanoma, you were more likely to partake in those behaviors. So even though we weren't anticipating some type of activity for the average risk people, I feel fortunate that it's in the direction, at least that is, you can hypothesize that, even though we're telling them they're at average risk, they actually have a family history of melanoma and therefore are acting in a fashion that we would like them to act. In the Hispanic study, we measured familism, which is a construct typical in Latino families. And we found that among higher risk individuals, those who had higher familism were more likely to have a skin or self-partner examinations. So we found that familism was a moderating factor. So the short answer to my long answer is yes, it does appear that family structures can impact individuals' behavior change in the context of receipt of genomic information.
Thanks, Peter. I can see Amelia's got something to contribute. Do you want to say something?
Oh, yes, I was going to add that in our pilot study research, we conducted qualitative interviews with participants, and we found that people were communicating about their genetic risk information, but also about preventive behaviours with their families. And that was prompted by the risk information that we provided them with. And we also measured it in the questionnaire, and we saw that communication with family members wasn't dependent on their level of risk that they were given. So all participants across the board tended to be talking with their family members about sun protection and their personal risk information. So that might also be a kind of teachable moment that Jennifer mentioned that could maximise positive impacts from providing this type of personalised risk information.
Yeah, and we did see a higher than expected proportion of people in the study with a family history. So I think that was a motivator to participating in the first place. But when we did do subgroup analyses that looked at the effect of the intervention by family history, I don't think we saw any significant differences by that. But yeah, it's quite an interesting topic. When we did the pilot study, we recruited through a more select group of people on a cancer research database, and the participation in the study then was much higher, around 40-something%. So it obviously has a role. Jennifer?
Yeah, no, I just wanted to add that, you know, we're looking at our family communication outcomes right now and finding, you know, interestingly, that family communication about skin cancer went up in all of the groups. Just being a participant in the study, whether they pursued testing or didn't pursue testing, actually, you know, prompted family communication. So I think that we shouldn't minimize the extent to which average risk feedback is helpful in some groups, like is, you know, like Peter was saying, is that, you know, just getting that average risk feedback may serve as a prompt, especially if they have other risk factors that they need to pay attention to.
Great. I'm going to ask a question now about implementation. There was a question on that in the Q&A, because we did have quite different ways of recruiting to our studies and to the way we did the risk assessment. So Jennifer, I think the use of the internet was a novel way to do that. And I'm wondering whether you think that's, what do you think about that approach if it was to be implemented in the community versus direct to consumer versus, you know, through a health professional?
Well, you know, I think all of those methods have strengths and drawbacks. What we did in our studies, we modeled our design after the multiplex study, which maybe some of you have heard of, that came out of the National Human Genome Research Institute. They included MC1R and then common markers for other diseases. And so we wanted to really allow participants to make their own choice about whether they wanted to learn about MC1R testing and then ultimately to, you know, decide if they wanted to get it. So the use of the internet was a good, you know, a good solution to that, and really kind of mirrored the direct to consumer context. So once they received, you know, we had a face-to-face contact with them in clinic. And then for those randomized to the intervention arm, they received an invitation letter and a code so that they could, you know, decide on their own whether they wanted to do it with a family member, alone, not at all. And so it allowed us to really estimate you know, if MC1R was available to a general population, very diverse, what proportion would go and do it? So that was the reason that we designed the study as we did. And then the website that we developed had four modules around information and then comprehension questions. So they had to work through all 4 of those modules to request testing. So all of that was delivered via the internet.
Thanks, Jennifer. I've got a question for you, Julia, that we often come across in the field of precision prevention in general, and that is that we all know in public health that social determinants of health have a huge impact on health outcomes. And should we be focusing on this issue at all, or should we be redirecting our resources and efforts on addressing those social determinants of health?
Thank you. That is an excellent question. And I think we probably all agree that the social determinants of health are incredibly important, and that there are unfortunately existing inequities in access to health and in health outcomes, and that it is absolutely a key public health priority to address those. So I don't think that is going to change over the next years or potentially even decades, and that will remain incredibly important. So the way I would think about genomics and its potential for precision approaches is as another piece of the puzzle that's complementary to this, and that can help if we integrate the social determinants as well as lifestyle and medical history risk factors and genomic risk factors to really think about comprehensive approaches that reflect individual as well as societal differences between people, and how we can best use that to target the right intervention to the right population at the right time.
I think an important aspect is to assure that as we move forward in our precision prevention efforts, we don't contribute to inequities. You know, we don't contribute that. So anyway, that's about it.
Yeah, that's an important point. Maybe one question to finish off, if we're thinking about moving the research forward. Amelia, I know you were involved in the organising committee, and I think you spoke at that conference too, Peter, for a, well, I'll hand over to you to describe what the conference was, but thinking about what did come out of that conference in terms of what might be needed to move the field of precision cancer prevention in general, not specific to melanoma, but to move the field forward.
Yeah, so Julia is also involved in this collaboration now of early career researchers who align themselves with working in precision public health. And we held a conference online last year. It was called the Transdisciplinary Conference for Early Career Researchers Working in Precision Public Health. And that was really brought about by a need to bring together people who are starting out their research careers in precision public health and could benefit from opportunities to collaborate and meet with other researchers, because it is a very multidisciplinary field. And the main things that came out of the conference were identifying the key challenges and aims for us as early career researchers. And that was looking at the big issues which we've already really covered. So equity, access, and involving diverse populations in implementation research studies, and also building our genomics databases to include more diverse populations as well. An interesting point was also the need for frameworks to guide precision public health research, because it is really at the intersection of clinical and public health, I suppose, values and theories. And as a kind of a new field, there is a need to develop different frameworks to guide research and clinical application, particularly around ethical considerations and different norms related to that. So I think that's probably the key summary. Julia, did you want to add anything further?
Maybe one small thing to add to that is that capacity building is going to be a huge challenge for the successful translation implementation of these approaches, especially if they're going to be delivered through the health system. Then that's something that's come up again and again as a key factor to consider.
Absolutely, yeah, thank you.
Great. Well, I think that's a really nice way to end our flagship seminar on precision prevention of melanoma. So just join me again in thanking our speakers, Dr. Julia Steinberg, Dr. Amelia Smith, Dr. Peter Konetsky, and Dr. Jennifer Hay. It's been a real delight to discuss the findings of our very complementary studies. And thank you everyone for joining in, and we'll see you next time.